Textbook page 353, question number 3, by Newton Zheng. An electron enters a parallel plate apparatus that is 8.0 centimeters long and 4.0 centimeters wide. The electron has an initial horizontal speed of 6.0 times 10 to the exponent of 7 meters per second. The potential difference between the plates is 6.0 times 10 to the exponent of 2 volts. Calculate the electron's velocity as it leaves the plates. Alright, so the first thing that we have to do for this question is to draw a diagram and state all of our givens. So first we're given that the electron has an initial horizontal velocity of 6 times 10 to the exponent of 7 meters per second towards the right. Next, since the SI unit for all of our formulas are in meters, I converted all of our measurements to meters. So the length of the parallel plates is 0.08 meters, and the width of the parallel plates is 0.04 meters. We're also given that the parallel plates have an electric potential difference of 6.0 times 10 to the exponent of 2 volts. Now taking a look at this situation, we know that there's an upward force on the electron because the negative plate is below the negatively charged electron. And since like charges repel, the negatively charged electron would go upwards. So for this question, what we have to do is we have to solve for the final velocity of the electron as it leaves the parallel plates. And since there's an upward force on the electron, we know that there will be both a horizontal velocity and a vertical velocity. So let's get started. Our first step is to find the magnitude of the electric field. And we can solve that by dividing the electric potential difference with the width of the parallel plate. And that gives us an electric field of 1.5 times 10 to the exponent of 4 newtons per coulomb. For the next step, since the situation is a parallel plate, we know that the electric field is constant, and therefore Newton's second law applies. So we can use F net equals ma to solve for the acceleration in the vertical direction. For the F net, that's actually equivalent to Q epsilon. So we sub that in and divide that with the mass of the electron, and we get a vertical acceleration of 2.63 times 10 to the exponent of 15 meters per second squared up. Then we can use the horizontal components to solve for time, because we know that time is the same for both the horizontal component and the vertical component. And we can solve for time by dividing the length of the parallel plates with the initial horizontal velocity. And by subbing in the values, we will get a time of 1.33 times 10 to the exponent of negative 9 seconds. With the acceleration in the vertical direction and the time, we can now solve for the final vertical velocity of the electron as it leaves the parallel plates. Since we know that the initial vertical velocity is 0 and that the acceleration is constant, we can use VYF equals AY times delta t to solve for the final vertical velocity. And by subbing in the values, we will get a final vertical velocity of 3.5 times 10 to the exponent of 6 meters per second. As for the final horizontal velocity of the electron, since there is no force acting in a horizontal direction, it will be the same as its initial horizontal velocity, which gives us a final horizontal velocity of 6.0 times 10 to the exponent of 7 meters per second to the right. Now that we have our final vertical velocity and horizontal velocity, we can draw out a diagram of the situation and find the final velocity with the direction. So first, let's find the magnitude of the final velocity of the electron. And we can see from the diagram that we can simply use Pythagorean theorem to solve for the magnitude of the final velocity, which gives us 6.0 times 10 to the exponent of 7 meters per second. And then the final step is to find theta. So to find theta, we can use our knowledge of primary trigonometric ratios for right angled triangles. So tan theta would equal the opposite side divided by the adjacent side. So to solve for theta, we take the inverse of tan times the vertical velocity divided by the horizontal velocity, and that gives us an angle of 3.3 degrees. So for our final answer, the electron's velocity as it leaves the place is 6.0 times 10 to the exponent of 7 meters per second, 3.3 degrees above the horizontal, or in other words, east 3.3 degrees north. Thank you for listening, and I hope that now you know how to solve textbook page 353, question number 3.